All right, well, we've looked at understanding the different types of fractions. We've talked about the concept of equivalent fractions. Now let's take a look at reducing fractions into their lowest terms. In this example, we have the same fraction, 60 over 90, and we're going to look at a couple different ways to reduce fractions. In the first method, we're going to look at what we call reducing fractions using the greatest common factors. And you can think of a factor as a number that divides into another number. Let's take, for example, the number 10. What numbers divide into 10 evenly? Well, 2, 5, actually 1 and 10 do. So there are 4 factors of 10. 2, 5, 1, and 10. So we need to do the same thing with 60. Let's find common factors. Now, one thing I've noticed when I'm looking at the number 60 and 90 is they both end in 0. If they end in 0, that means that they both are divisible by 10. So if I divide both top and bottom numbers by 10, let's just go ahead and write that out like this. That will give us 6 over 9. Sometimes you'll see students just put a slash through the ending zeros and then they get directly to the 6/9. But then when you look at 6 and 9, you say, well, wait a minute, they're both divisible by 3. And when you divide both 6 by 3, 6 by 3, if you divide, is going to give you 2. And then 9 divided by 3 gives you 3. So we have reduced 60 over 90 using what's called common factors. Now, let's say that you didn't know that. If you know that 60 and 90 are divisible by 2, you could have started there. For example, 60 divided by 2 is 30. And then 90 divided by 2 is 45. Now, using this method, you just really have to be good with your division. Now, you might look at this and say, wait a minute, they're both divisible by 5. 30 divided by 5 is 6. 45 divided by 5 is 9. And once again, we recognize they're both divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And we've gotten the same answer here. All right, what about the other method that we're going to look at here? It's called the prime factorization. Let's go ahead and scroll down here so we can get some more white space, and I can show you how to do that. Now, the prime factorization is a good method, and what we do is we start by writing each of the numbers that we have. The numerator is 60, and what we do is we break this down. Now, how you break it down does not matter. So what times another number will give you 60? Well, let's do 3 times 20. 3 is a prime number. It cannot be broken down any further, but 20 can be. 20 can be broken down into 4 times 5. And don't worry, if you had said 2 times 10, it's going to give you the same thing. It just doesn't matter how you break it down. 4 can be broken down into 2 times 2. So we have that. Well, the 5 is already prime. So you keep breaking down numbers until they can't break down any further. So what we're going to do then is just rewrite this fraction as its prime factorization. I'm going to put them in order. I have 2 2s, I have a 3, and I have a 5. So if you want to confirm this, 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. So we broke that down correctly. What about 90? Well, again, it doesn't matter how you break it down. It just has to be true when you do so. So 9 times 10 is 90. But then I can break down 9 into 3 times 3. Well, 3 is a prime number. It's a prime number there. Neither one of those can be broken down any further. What about 10? It breaks down into 2 times 5. Once again, the 2 and the 5 are prime. So I'm done. None of these numbers can be broken down any further. Putting them in order, I have 2 times 3 times 3 times 5. Now, I'm going to do this out of order just a little bit. I have 2 times the 5 is 10. 3 times 3 is 9. 9 times the 10 gives me 90. So it is broken down correctly. The benefit of using the prime factorization method is that now we can cancel the common factors. And when we do that, here's what we're saying. We're saying 2 divides into 2 once. It divides into the other 2 one time. Then we can cancel out 3's. 3 goes into 3 once. It goes into the other 3 one time. And then finally we can cancel the 5's like this. And we're saying really the 5 goes into 5 once, into the other 5 one time. So on top, we're left with 1 times 2 times 1 times 1. So multiplying all four numbers on the top gives us 2. On the bottom, 1 times 3 times 1 times 1 is 3. So we got the same we got the same reduced fraction as we did in the examples above here. Okay? So let's take a look at another example. So in example 2a, we're trying to reduce using the greatest common factors method. We have 210 over 225. Well, if numbers end in either a 0 or a 5, I know they're divisible by 5. So again, I'm trying to find the greatest one, but I honestly just don't know what it is. So I do know 5 divides into this. So 5 divides into there. I believe that's 42 times. 5 divides into 225. That's going to be 45 times. And I just happen to know that both 42 and 45 are divisible by 3, so I'm going to divide both by 3. 42 divided by 3 is going to give me, I believe that's 14. And then 45 divided by 3 is going to give me 15. So I reduced it and I got 14 over 15. So if you found a larger number that divides evenly into 210 and 225, that would have given you the answer a little more quickly. But it took me 2 steps, but I finally got there. So let's go ahead and look at the prime factorization method. And once again, we need to get the same answer, so let me just see what that answer was again. So that previous answer was 14/15. I want to make sure we get the same answer. So we start again with 210, and again it ends in 0, so I know I can do 21 times 10. 21 can be broken down into 3 times 7. Those are both prime numbers. 10 breaks down into 2 times 5. So far, putting them in order. You don't have to put them in order if you don't want to. I just like to do it because it kind of helps me keep organized there. I have a 2, 3, 5, and a 7. And then 225. I know that's 5 times, what is that, 45? 5 is prime. 45 breaks down into 9 times 5. 5 is prime. 9 breaks down into 3 times 3. So I have 2 3s and 2 5s. Let's try that again. 2 3s and 2 5s. So I'm just going to go ahead and cancel out the 3s and the 5s. And remember, the reason why that works is because 3 divides into 3 ones and it divides into the other 3 one time. So anyway, we're left with on top 2 times 1 times 1 times 7, which is equal to 14. And then on the bottom, 3 times 1 times 1 times 5 is 15. So we get the same answer, again, just by using what's called the prime factorization method. So it just appears to me that that working with fractions and reducing them is all about being good really with division. So as long as you have that down, the basics of it, then you should be good to go. One other thing, if you have this calculator that I have here, it also reduces fractions for you. I'll type in the 210. I'll press the numerator denominator button, which makes it a fraction, over 225, and press enter. So it gives me 14/15. So, a lot of ways to do this. Obviously, the calculator is pretty darn easy to do, but you should be able to do this by hand as well. So anyway, hope this helps.